Folks, I'm really delighted to be here today, so thank you for SmartSheffield and Alan for hosting. I'm going to give you a bit of an update on the green barriers. I wish it was a simple story, but like everything else, it begins to get complex. Just to give you a bit of background, I'm in the Department of Landscape Architecture, and I'm not a centre specialist, so I'll take the technical questions away, but I'm a plant biologist, so my interest really is on the biological side of the story. And we are a group that basically is interested in urban vegetation in general. I'm going to talk about air quality improvement this evening, but that's just one of the services we're interested in the green stuff providing to the city, whether it is things like storm flow management, capture, the green sponge sort of approach to water management in the urban situation, whether it's about keeping our buildings and our urban heat islands low through the use of trees and other vegetation, and as well as actually building insulation in winter as well as in cooling in summer, actually providing better insulation through good design around a building is one of our interests. It also verses into the human element, that plants actually provide a range of psychological benefits for health, and increasingly we're finding these relationships through chemicals of plants and the microbial biomes around plants directly affecting things like gut health and mental health. And of course the whole agenda that tends to be around the biodiversity crisis and trying to improve habitat within the urban matrix, all of which depends on our plants surviving. So climate adaptation is also in that mix, and just how tolerant, resilient our plant species can be. Anyway, I'm here really to talk about air pollution and give you a bit of an update on the green barrier. You're probably aware of the background. 9 out of 10 people breathe polluted air, kills globally about 7 million people per year directly, but it's also one of these subliminal things that affect so many of our key diseases, whether it's cancer, heart disease and stroke, where poor air quality throughout our lives are contributing to a loss of longevity. And the real tragedy is that we're still not learning, and today, even though we had the pea supers back in the 1950s, understood that they related to pulmonary health, that even today, too many of our children who are developing with young lungs are exposed to poor quality air. The pollutants we're aware of course, are particulate matter, so small bits of smut, diesel particles, other organic particles coming together, sometimes with heavy metals and other components, in usually from either traffic or from some form of combustion process. Nitrous oxides and oxides, various oxides of nitrogen, which also have implications for heart health. And then more complex things like ozone, which is a combination of solar irradiance and other pollutants that can then release ozone into the atmosphere. Carbon monoxide, obviously in limited areas where it doesn't bind onto another molecule of oxygen, so it's searching for oxygen out of your blood system. So we won this project. I always feel sorry for this particular PhD student. So this was a PhD project we won, and it was looking at Hunter's Bar School with the idea of a green barrier, a new green facility around the school to see if we could improve air quality. And this poor PhD student we employed was very, very capable. She ended up with 5 different supervisors, so it's almost a nightmare as far as a student is concerned. Pulled in all different directions. The principle, though, was to look at the vegetation being a barrier, because we know that sometimes vegetation interacts with air pollutants in a variety of different ways. If you can create a screen or a barrier, then you can tend to limit the amount of exposure on the right side of the barrier. Always keen to remember that if it's on the wrong side of the barrier, you may actually make it worse, depending on where the source of the pollution is and where the area that you're trying to make things better. So the PhD, Maria, she was here for 4 years because it ended up with extensions because of, I'll come on to in a minute or two, but basically this was her study site, Hunter's Bar School. You've got Exall Road there, quite a lot of pollutants gathering around the roundabout area, and the barrier very much kind of put into this triangle as a protection, with the school children playing much of the time on this part of the playground. So what plants do we plant? Well, we know from the literature that there's 2 key mechanisms when it comes to trying to trap aerial pollutants and vegetation. It's more complex than that because you get microbial degradation as well on the plant, as well as the activities of the plant itself. But in general, plants that have a waxy leaf, slightly sticky, slightly tacky, or have a very fine structure tend to be the ones that can adhere to these pollutants more effectively. So you're kind of thinking about filters that are big glossy leaves and fine feathery type leaves. The barrier was installed. We brought in a landscape company to install it in 2019, and we used a combination of different types of plants, conifers, bamboos, etc. We also had an aqua mesh positioned about 10 metres from the barrier in the middle of the playground, and we also had 2 nitrous dioxide sensors near the barrier itself. Because we only had one monitor, we actually had to rely, or one key monitor, we had to rely on before and after data, which itself, of course, is challenging. So what did we find from our main study? Well, unfortunately, we had this thing called a lockdown. So that before and after kind of buckered things up somewhat. The interesting thing is, during lockdown, we saw a 25% reduction in NOx, or a 21% increase in PM recorded before and after the system. So we actually got an increase in our key pollutant. Any guesses why?
Everyone was at home.
Doing?
Eating.
Wood burn stoves, other things like that. More people at home, more domestic pollutants coming into that field, but less carbon from less pollutants coming from cars and other traffic. When we did cut and paste some of the data to much smaller time segments, we did get a more positive story. So we see a reduction when we compare like with like of about somewhere between -15, -20% on NOxes, but a much less key impact on the PMs themselves. So it's moving in the right direction, but it was not particularly spectacular. We did find, however, looking at the different plant types, that they were picking up the PMs, and at different types of plant on different sizes of PM. So different particular matter was adhering to different parts of the plant. So this is the underside of the leaf. This is the stomata structure where the plant breathes. And you can see that in these little crevices and cradles in the plant leaf, you're getting the smuts adhering to them. Different plants picked out different pollutants. Probably best overall was the conifers, not so bad either. The ivy and then the bamboo was the less affected, largely by the microdynamics of the structure of the leaf and the structure of the pollutant. So it's more complex than just everything screams everything. So we did unfortunately get a bit of a confused picture due to the COVID lockdowns. It was a much shorter term study where we can actually kind of compare like with like than we had hoped for. And so we really do need more data around this type of year, November through to February, the winter time data, when we know that days like this, when you've got still air, the pollutant levels tend to go up. We found though that from our preliminary studies, the vegetation tend to be better for the nitrous oxides than the PMs so far, and the different plants have different scrubbing characteristics. Just to put it into a slightly bigger context, this is our data. So this is the PM, a slight improvement, but not that much, and nitrous dioxide, a much more significant improvement. Remember, our barrier's thin, it's really thin, it's about 3 leaf depth. It's a tiny little scrape, it's not a big filter. When you bring in some of the other studies where the vegetation is wider, 2 to 3 meters wide, for example, the story becomes much more positive. So one of the key things is bang in as many plants and make that barrier as wide as you can, given the space available to you. The interesting other point is these are bars showing the variance. So although the mean's in there, you've got quite big variation, and that's because of weather, but also some of the sources of the pollutant changing with time. So it's a complex picture. It isn't just that the source is always in the one direction. And what I was saying earlier about making sure you don't trap in stagnant air is quite important. But nevertheless, with the right sort of systems, we feel confident we can sort of clean the air up by about 50% when we have all the things, all the ducks aligned in a row, as it were. Poor Maria, she not only had to look at the air quality, she actually had to look at all the other environmentals. It was a multidisciplinary project, so it's economic, environmental, and social. And most of those stories are really positive. The green barrier improved children's engagement, improved activity levels, improved attention span, and also gave us sort of what we call a stronger sense of place. People started coming to the school, putting their kids in the school because of the green barrier. Okay, we want to get more harder quality data. So we've actually taken our original AQ mesh and we've stolen 2 or 3 others from the Urban Institute, don't tell them, but we're going to bang them in beside the Children's Hospital. Slightly political. But what we're going to do is have one right by the side of the roadside, one halfway between the wall and one in the wall. And we're actually then going to move in different types of plant, different densities of plant, different numbers of plant for a like-for-like comparison over time. So we can compare 2 days with the plants there, 2 days with the plants not there, 2 days more with the plants there. Ringing the mix, ringing the variables. Thank you very much.